Hello. So this is just an update to what I'm up to over summer. I'm doing a bit of programming and I'm going to try and remake Manic Miner in Python. So this here is a Spectrum emulator which loads the actual Spectrum code in and runs it very authentically. So let's just have a little go. So this is a game I played quite a lot as a child. It was probably my favourite game on the Spectrum, and it's certainly one of the best Spectrum games ever. It's still very, very playable, and this level is ingrained into everyone who played it. So I thought I'm going to give this a go, and I'm going to see if I can remake it. Now, I know in the Wireframe magazine, quite recently, issue 49, they had a go at showing how you could make a simple version of this in Python with the disappearing levels, and I thought that's really interesting. I'm going to have a look at that. I decided to use Pygame rather than Pygame 0 because I needed to do a few extra things that I wasn't sure that it could handle. So let's have a look at how far I've got, and then I'll talk through a few of the more technical details. So I've only been doing this a few days. So this is where I've got to up to yet. Now I know the colours are not exactly the same, but we can move. The platforms don't work yet. I've not implemented that. So I've been spending nearly all of my time getting the character to be pixel perfect in every way. So let me just resume that. So it's at the same scale. I'm actually drawing this quite small and then scaling the surface up. So but what you'll notice is that the pixels, they're identical the way he moves. The frames, if I move here next to this, you'll see that it's identical, and if I press left and I press left, it's all pixel perfect. And that's because I gathered that he must have used the screen space for the frames, which is something I like to do because it just makes coding animation easier. So rather than have frames of animation depending on time, you have the frame of animation that depends on where you are. So you normally use modulus for this. So if you're at position 10 and you take modulus 4 of it, that means you're on frame 2. So that's the method I went down, and I think that he did too because it matches exactly. There was one little slight hiccup to that method in that the character moves 2 pixels at a time, so that means the modulus will always be even, so I won't be able to get to frame 3. So to fix that problem, I halved his position. So if he's at position 100, he'll be at position 50, and if he's at position 102, he'll be at position 51, and then I can take the modulus of it to get the odd frame. So that was that. The second challenge was jumping. I'll just do this before I run out of air. So with the jumping, he follows a very specific pattern, and I've counted the frames by running it very slowly, and it's 18 frames long, and he jumps 20 pixels high. And I once remember watching an interview with Matt Smith in which he talked about plotting it on a piece of graph paper as a quadratic. So knowing that it was 20 pixels high and 18 frames, I had to go at plotting it, and that's what I got. And then I carefully observed, very painfully, watching him jump and moving pixel by pixel, and confirming that that is the pattern that he took. And then I took this, so he moves 4, 4, 3, 3, 2, 2, 1, 1, and so on. So I made a, don't know what happened there. Let me just stop this. So the way that I handle this jumping is in a list. I'll probably take the list out actually, because it follows such a simple pattern. It just, every 2 frames it goes down by 1. So, and then it reaches a terminal velocity, and then he dies if he hits anything after that. So that's fairly simple. The other thing of note that isn't super obvious and different from some other games is that when you're moving, he seems to walk at a constant speed of 2 pixels, but if you notice, the width of the character here is only 6 pixels, and yet the width of the character here is 10 pixels. So he actually changes size, width, which is a bit unusual. So I created an offset in his X position. So this frame here has no offset, but when we move to the next frame we have an offset of 1. Actually it's this one, that's got an offset of 1 extra pixel, because it's smaller, and it'd actually be standing still between those 2 frames. He wouldn't move, and then it would go really weird. And then for this large frame here, we actually have to move him back 1, otherwise he appears to jump forward, and it looks really weird. If all those were zeros, I could show you actually. Let me just I was experimenting with this quite a lot until I got it to work. Let's just quickly change them all to zeros, and you'll see what I mean. Whoa, 0. Is that enough? Probably need to make it enough, otherwise I'll crash. Okay, so yeah, if I run the animation now, it's just gone onto the other screen. I wondered where it had gone. And then move. Let me just close that down and run that again. Oh, I know why. It's because I've started it on there instead of the proper level. Here we go. So now he has this really, really weird jerking motion, because he's actually from here to here, he sort of skips a step. So I had to do some frame offsetting there. That was my initial idea, but it didn't work on the return. When he turns around, it's a little bit different, so I had to change it to ensure that he's in the correct position when he turns around. I'm using a list of sprites, so I also have my own sprite block. So I'm using black and white sprites and then colouring them in like this grass. So when you look at the actual level, they're coloured, and the keys will flash, or hopefully they will flash, using this method of blending, alpha blending. I think it's alpha blending. Let's have a look. Different blend modes. It's in this one here. Blah 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 blah. Yeah, multiply I'm using on that one, and then I was using RGB subtract on that one. So yeah, you can actually load them in. The other thing that will change soon is the map is just a 2-dimensional array, and this will actually be in probably a JSON file, and I will load it in, and then I will parse the map. So that means I can create separate files for each map, and then make additional levels. And these letters, I might change this, but that's for a key. In another map it might be a tennis racket, and it might have the same letter still. I'm not sure. Obviously I've got the enemies to put in. Here we're just drawing the walls, drawing the tiles, drawing the blocks, and so on. And it only draws blocks if it's a block, it just ignores the others. So it's fairly efficient, and it's also drawing it quite small, and then the output is scaled up, so we could actually play it at a small size and it will work just the same. So I think this is a more authentic way of doing it. It's a faster way of doing it as well, as it uses SDL, so we've got accelerator graphics, just scaling that up, so this should be quite fast and nippy. So yeah, that's where I'm up to, and I'm going to keep working on it, and I'll do another video to show you the progress. Cheers, thanks a lot.